Now let's talk about completing the square. The idea with completing the square is we take a standard form quadratic function, ax squared plus bx plus c, and through completing the square, turn it into its equivalent vertex form. We go from standard form to vertex form. That's the big picture behind completing the square. So let's walk through an example to see how to do it. Let's look at x squared plus 2x minus 3. The idea here is we want to figure out what we can do to the first two terms that have x in them so that it will factor as a perfect square trinomial. And perfect square trinomials have that form a squared plus 2ab plus b squared, and they factor into a plus b squared, or we can have a minus sign, and that'll cause a minus in our factoring. So this is that special form, special polynomial that we want to try to turn this quadratic function into, but we're going to have leftover bits, and that's where the plus k part comes into, and also the a. In this case, though, a is 1, so we're not having to worry about the a right now. I'm going to back this up just a little bit, and let's look at our original function, x squared plus 2x minus 3. The first thing I'm going to do is move that minus 3 far over. I don't need the negative 3 right now. It's just going to hang out on the side. But I do need to figure out if there's something that I can add so that x squared plus 2x plus what I add will factor as a perfect square trinomial. Well, if I look over here in my formula, x squared plus 2x plus what? I need b. Well, a is x, 2 is already here, so what is b? B needs to be 1, because if b is 1, I will get a perfect square trinomial of x plus 1 squared. So I need to add a 1. Oh, wait a minute. This is not an equation. It's a function. Functions are not equations. Even though there's an equal sign in there, the function name is this expression. So be really careful with this. I can't just add. That's not allowed in math. I don't get to just add whatever I want to, wherever I want to, in an expression or a function. But what I am allowed to do is add 0. I can add 0 to whatever I want to. And that 0 can take many forms. Just like when we were multiplying by special forms of 1 to simplify rational expressions, for example, or to get rational expressions to have common denominators, we weren't really multiplying by 1. We were multiplying by an expression over itself that is equal to 1. Well, plus 1 and minus 1 equals 0. I'm really adding nothing to the function, but I'm adding it in a way that allows me to factor in the way that I want it to. So here, x squared plus 2x plus 1 will factor x plus 1 squared. And then I take these pieces over here, the negative 3 minus 1, add them together. Negative 3 minus 1 is negative 4. So my general form, my standard form, has now become my vertex form simply by adding 0. Now, I know I made it look simple, and we're going to talk about how to find this value that we need to add and subtract, because it won't always be obvious. There is a procedure that we can use. A couple of things I want to point out before we dive deeper, though, is that in my vertex form, k is negative 4, h is negative 1, opposite what's inside. Because of this vertex form, it's x minus h. And so this will tell me immediately, just by reading off on the vertex form, what my vertex coordinates are. It's pretty convenient. But now let's talk about that plus 1 minus 1 thing. How do I know what to add and subtract? I see this middle term, 2x here, okay? 2x. It already existed, so that's how I knew my b was 1. Let's try one more problem before we talk about how to find this 0 that we add and subtract to our function. So let's do another example. F of x equals x squared plus 6x plus 5. So the first thing I do is I move that 5 out of the way so I have some space here. When we're doing the completing the square part, we're always adding to our x terms, and then we subtract at the end. There will never be a case where this inside is negative, because completing the square is always a plus b squared at the end. So we need to figure out x squared plus 6x plus what will get us a factored form. And if we go back to our perfect square trinomials, x squared plus 2xb plus b squared would factor into x plus b squared. And the b that I'm using here is not the same as the b that's in our quadratic. It's a different b, but let's see if we can reason it out. So I have x squared matching. Here I have 2xb and 6x. These two things have to be equal. 6x, 2xb. Well, I can drop the x's. Those aren't important. 6 is 2b. So the b that I need, 3. If I had 3 squared there, this would be x plus 3 squared. I need to add 3 squared and subtract 3 squared into my function. 3 squared, that's 9. So I add and subtract 9. Let's see if this works. X squared plus 6x plus 9 will factor as x plus 3 squared. We already determined that over here on the right. And then plus 5 minus 9 gives us a negative 4. And there we have our vertex form, x plus 3 squared minus 4. Pretty cool. Let's try just one more, and then I'm going to show you why we call it completing the square. One more example. This time we'll have a negative in the middle. 3x squared minus 12x plus 10. Now remember, our goal is to get it into ax minus h squared plus k. So this a is already outside of our factoring. When we have a that is not 1, we have to factor it out of just the first 2 terms. We don't care what happens with the last term. Just like before, the last term just hangs until we're ready to add it to whatever it is we're subtracting. So the first step, factor out the 3. Just from the first 2 terms. I'm going to put that plus 10 way over on the side. So 3x squared minus, factor out a 3 from 12, we get 4x. And this time I'm going to put that parentheses farther over because we need to add something inside this parentheses this time. And when we add something inside this parentheses, I want you to notice we're not just adding that number, we're adding 3 times that number. So we need to subtract 3 times that number on the outside. Remember, we can only add or subtract 0. So the fact that we factored out a 3 and we're throwing a number inside a parentheses being multiplied by 3, we need to subtract 3 times that same amount on the outside, making sure that that's clear. Now, take a look at our x squared minus 4x. And I'm going to kind of try to do this on the side. X squared minus 4x plus something has to factor x minus something squared. It's a different something. Not sure what it is yet. But just like before, the middle term is always 2 times a times b. A is x squared in this case. So I'm looking for that b in the middle term. So we could set up this equation again, but guess what? This is going to happen every single time. The x's drop out. Some number over here equals 2b on the right, and then we divide by 2. So instead of having to do that step over and over and over again, we take the middle term, and we're just going to focus on the number, -4, divide by 2, and then square it. So -4 divided by 2 is -2. -2 squared is 4. This number is going to become important to us too, so hang on to that -2 before we square it. So we're going to add 4 and subtract 3 times 4 on the outside. When we do that, x squared minus 4x plus 4, this factors as x minus 2 squared. Think about it for a second as far as the factoring goes. See if you can come up with the factoring for that quadratic. But notice, minus 2, minus 2. This will always happen when you're completing the square. The number that you get before you square it is what ends up in our factored form. And then the last part of completing the square for this particular function, plus 10 minus 12, 3 times 4 is 12. We need to simplify that out. X minus 2 squared minus 2 on the outside is our vertex form of 3x squared minus 12x plus 10. And our vertex, we can read it nicely off of this graph. We have a vertex of 2, -2 for this parabola.